Good evening, everyone. We are the Group 11, and today we are going to discuss about the concrete pavement with the reporters, yours truly, Alamban Eliana, Antovia, and Kanaman Ray Joshua. First, we have the Portland cement. Now, Portland cement is a combination of limestone, marl, or other calcareous materials and clay shale, or like argillaceous substances. So in the DPWH book, this belongs to the item 311, which is the Portland cement concrete pavement. So its description is, this item shall consist of pavement of Portland cement concrete with or without reinforcement, constructed on the prepared base in accordance with this specification and in conformity with lines, grades, thickness, and typical cross-section shown on the plans. Now, there are different types of Portland cement specified by AASHTO. First, we have the type 1 or 1A, air in training. This type of cement is for general concrete construction when the specified properties of the other four types are not required. Simply, ang explanation niya is, ang type 1 normal Portland cement lang siya or general use cement. Next, we have the type 2 or 2A air in training. This type is for general concrete construction exposed to moderate action or where moderate heat or of hydration is required. In addition, it is used for structures in water or soil containing moderate amount of sulfate or when buildup is a concern. Next, we have the type 3 or 3A, and this type of cement is for high strength concrete and high early strength po ni siya. And it is desired at very early periods. Next, we have the type 4. It is for low heat of hydration, and it is used where the amount and rate of heat generation must be kept to a minimum. Lastly, we have the type 5. It is for high sulfate resistance, and it is a sulfate resistance Portland cement. It is used where the water or soil is high in alkali. Now, generally, Portland cement constitute the following chemicals. First, we have the tricalcium silicate or the C3S, dicalcium silicate C2S, tricalcium aluminate C3A, and tetracalcium aluminiferrite or the C4AF. Now, the tricalcium silicate, it is the main product of this reaction with water is calcium silicate hydride, a nearly amorphous material which primarily contributes to the strength and volume stability of cement-based materials. Next, we have the tricalcium aluminate. This kind of chemical is the most reactive component of the Portland cement and its hydration. It has an important impact on the workability and early strength of concrete. In addition, it accelerates the hydration process, it reduces the setting time, and improves the compressive strength. Third, we have the dicalcium silicate. It hardens slowly and provides much of the ultimate strength. And it is one of the important constituents of Portland cement. This contributes to late strength due to its lower reactivity. Lastly, we have the tetracalcium aluminiferrate. C4AF contributes positively to the compressive strength of cement at 12 hours accelerated curing to 3, 7, and 28 days normal curing. Now we have the table 8-1. It is the composition and strength characteristics of various types of Portland cement. Now, as you can see, in the types of cement, we have the type 1, which is the normal one. We can see it is fairly high C3S content for good early strength development. So the C3S is 50. Next, we have the type 2. Ang type 2 na to, low siya for C3A content, which is 5 lang. Tas sa type 3, it is grounded finely, may have slightly more C3S. So, yung C3S clearly 16 and so mas more siya kaysa sa normal. Tapos sa type 4, low content of C3S and C3A. So ang C3S na to is only 26 and ang C3A is 5. Lastly, we have the type 5 which is the sulfate resistance. It has a very low of C3A content which is 4. Next, we have the compressive strength normal Portland cement concrete percent. Sa curing ni siya 1 day, 7 days, 28 days, and 3 months. So sa normal, 100 lang siya. Tas sa modified, ga-decrease iyang tas ga-increase din pagka third month sa type 3 dayon since for early strength siya, dako iyang early strength which is 190 tas ga-decrease din pagka 3 months sa and sa type 4 and type 5 ga-increase siya, ga-decrease to tas mag-increase din pagka 3 months. Next, chapter 2, we have the concrete pavement characteristics and behavior. So for the characteristics, the behavior of concrete pavement that is exposed to loading environmental effect entirely depend upon the quality of the concrete. Quality of the concrete mo ni siyang physical and mechanical properties of aggregates such as shape, grading, durability, specific gravity, and water absorption. Next, underlying of subgrade ang unsay nasa ilalom sa subgrade, and last, the base course. Now, strong in resisting compression load acting on it, but considerably weak in resisting tensile stress. So therefore, ang concrete pavement acting as a beam resting on a weak subgrade and base course is also weak in carrying heavy load associated with impact forces. The reaction and movement of the subgrade supporting the slab affect the stability of the concrete pavement. Next, it expands and contracts due to temperature changes, and it expands when wet and contracts when dried. So, concrete, like other materials, also expands and contracts due to temperature change, Jud. And after pouring, concrete shrinks as the mortar hardens and the cement hydrates. And the concrete pavement changes in length with time of day for being exposed to different elements of weather changes. Lastly, a curl tendency is very likely due to the effect of daily and seasonal temperature and moisture differences between top and bottom slab. Now, in concrete pavement design assumes the following considerations. First, that the pavement slab was designed as plain concrete beams. Second, that transverse cracks on concrete pavement cannot be avoided. The designer, however, presumes that the pavement cracks could be controlled by providing reinforcements to the slab joints with the following assumption. First assumption is with reinforcement cracks on the slab will be confined to a weakened plane joint space at 4.50 to 6 meters in distance. Second is vertical offsetting across the narrow cracks will be prevented by aggregate interlock or by dowel bars. Third, with simply reinforced slab, cracks will only appear at weakened plane joints space at 12 to 20 meters interval. Hair cracks to be held tightly by the steel between joints. Fourth, with continuous reinforcement, transverse joints are omitted. Hair cracks are checked by the steel and develop at the close interval. Lastly, faulting is countered by aggregate interlock and steel bars. And third, for the consideration, the longitudinal cracks on the pavement slab more than 1 lane wide is inevitable. Lastly, pavement slab is supported by foundation that deflects when loaded but recover when the load is removed, assuming that the foundation materials are elastic or like a dense liquid. Now for the definition of terms, we have the deterioration. Now, it is deterioration of concrete pavement is due to stress brought about by load, moisture, and temperature. In addition, when concrete is exposed to waterborne sand and gravel, the surface gets deteriorated. Now, we have the distress of concretes. So, there are three categories of distress of concretes. We have distortion, cracking, and disintegration. Distortion. It is a vertical displacement of concrete slab at the joints or crack, and distortion is due to failure or weakness of concrete joints. And in short, ang distortion, it is a change in the pavement surface original position. Next, we have faulting. Faulting is the result of pumping tremendous force or load that develop under pavement. And causes of faulting is the loss of support and erosion of subbase. And faulting also results from a combination of factors such as inefficient load transfer joints, slab pumping, slab settlements, curling, warping, and inadequate base support. Next, we have the cracking. Cracking can take many forms in concrete pavements that could be result from applied load, temperature, or moisture changes. Now, there are common types of crack. We have the corner cracks and transverse cracks. Ang corner cracks muna siyang, it is associated with excessive corner deflection, while ang transverse cracks muna siyang associated with mixture or temperature stresses or poor construction method. Next, we have the disintegration. It appears in the form of durability cracking, scaling, or spalling as the result of mixed design or construction-related problems like first, we have the durability cracking. It results from freeze-thaw action. The scaling, it is a network of shallow, fine hairline cracks which extend through the upper surface of the concrete. And lastly, we have the spalling. It is the breaking or chipping of the joint edges. It is the result from excessive stresses at joint with concrete, poorly designed or constructed joints. Lastly, we have the changes in temperature and moisture content. Create slab curling, flexure stresses, and overall lengthening and shortening of the slabs. The tendency of the slab to shorten is due to temperature drop. Muna siya or drying that create tensile stress. As while the tendency of the slab is to lengthen due to temperature rise. It is the increase in moisture that creates compression stresses. Chapter 3, we have the control of cracks, and load transfer and joint alignment is sometimes dependent solely on aggregate interlocking. If the joint opening is considered small from 0.03 to 0.04 inch, the projecting aggregate is considered tightly keyed, and when the edge of one slab deflects due to load, the adjoining edge will also be forced down. Now, dowels can be painted, greased, or coated with asphalt for almost one half of their length to break the bond with concrete, allowing the dowels to slip within one of the abutting slab ends. Skewed transverse contracting joint in plain concrete pavement is being adopted. Joints are slanted 60 centimeters to each 3.60 meters lands from normal position. The offset places the inside of a double tire of a truck just forward of the joint, and at the same time, the outside wheels are just behind the joint. So, mag-icebreaker na ta, guys. So, nalang mo 5 seconds to answer, tas katagan ta mag-time, tas 5 seconds lang dayon para makatype sa chat box. Jumbled words ang atong icebreaker di ay. So, first question, it is caused by improper pavement construction, deterioration of the underlying base or existing asphalt, and high load factors. Tapos magulat yung din na sa signal. Pwede na mag-answer, guys. Stop na. Okay, kinsa na ko. So, ang answer is distortion. Ang nakauna kay si Maitel. Next question is two. It is one of the important constituent in Portland cement. It attributes to late strength due to its lower reactivity. Go na guys. Ang answer is dicalcium silicate. Nakauna si Krisha. And last question. It is caused by concrete's inability to withstand environmental factors such as freeze cycles. Pwede na mag-answer guys. Okay, stop na. Ang answer kay durability cracking and nakauna si Vicky. Next reporter, please.
So, good evening everyone. I am Roy Joshua Kanaman and let's talk about the transverse expansion joints, which is the continuation of our report. So, next slide please. Next slide please. So, expansion of joints are provide space allowance for the lengthening of the slab due to expansion. So, balik sa slide. So because of the so many buckling upward to concrete pavement, engineers have to come up with the conclusion that this blow up serves as conclusive evidence. So ang expression of joints kay mo siya ang joints that are used to absorb the thermal expansion. So they can also be used to absorb kaning contraction in say cryogenic lines and to reduce vibration in piping systems. So materials of construction for the bellows can be stainless or rubber or even a composite material. A concrete expansion joint or what we call kaniyang laing tawag which is a control joint is a gap that allows the concrete to expand and contract so as or when the temperature changes. So it forms a break between the concrete and other parts of the structures to allow movement without causing stress, which can lead to cracking. So there are many reasons expansion joints are required, such as structure size or the length, the structure shape or irregularities, the isolation of the similar building classifications. Sometimes there are the fire separation and lastly the thermal movement. So what happens if dili ta magbutang og expansion joints sa concrete? So if you have a concrete floor in your commercial building, you know expansion joints are necessary. So to allow for the natural expansion and contraction that occurs from temperature changes. So kung without these joints, large cracks can travel across your floor, so creating costly damage. So in the screen na ang graph dia which is recommended dimensions of the dowels for concrete pavement joints. So there are the pavement thickness, the dowel diameter, dowel length and meter, and the dowel spacing meter. So as the pavement thickness increases, uh, the diameter of the dowel increases too. So but ang ilang length of spacing kay same ra which is 0.45 meter and 0.30 meter. So example 15 di sa 15 nga thickness sa pavement 20 diameter sa dowel ang need. Then sa 17.5 25 sa 20 same 25 then sa 22.5 is 32 which is same pod ang diameter na 32 sa 22 nga thickness 25 and 27 and apil pod ang 30. So next slide please. So before ta mag-discuss aning basic type of concrete pavement joints, iingon sa nako tong purpose sa dowel sa concrete. Ang dowels kay located ni siya in transverse joints of jointed plan concrete pavements, and magamit sila to provide load transfer between individual slabs, reduce faulting and improve performance. So ang dowel is used for cylindrical rod, usually made from wood, plastic or metal, that is used for holding together components of a structure. So dowels are much thicker and sturdier than screws or nails, which as a result makes them perfect for furniture cabinet made. So dowel bars ang ginabutang ni siya sa kaning fresh bitaw na kanang bagong buhos na semento, then ang ilang kalagyon is 12 to 16 inches, then ang kataasan ni kay 18 inches long. So ang purpose is to transfer load from one slab to its adjacent slab, and to reduce joint failure and corner cracking, also to improve performance of pavement joints. So mag-move on na ta sa type of joints. So there are four types of joints, which is the contraction joint, the expansion joint, longitudinal joint, and the construction joint. So before to mag-discuss each joint, so what are those gaps or lines on the concrete? So the answer is joints. But asa gyud ni unsa gyud ang exactly joints in concrete, kanang unsa gyud iyang meaning sa concrete? So first of all, ang concrete is not a ductile material. Kuan siya, it doesn't stretch or bend without breaking. But ang concrete, ga-move, ga-shrink, ga-expand, and also different parts of a building move in different ways. So this is where joints come into play. So when concrete moves, it is tied to another structure or even to itself. So we get what's called restraint, which causes tensile forces, and invariability leads to cracking. So next slide, please. So construction joints, I mean contraction joints. A contraction joint is a sewed formed or tooled groove in a concrete slab that creates a weakened vertical plane. So originally between makita ni siya sa kalalumon so 1/4 to 1/3 the depth of the slab, and typically spaced every 3.1 to 15 meters. Next is the expansion joints. So this is to prevent cracks due to temperature changes. So ang expansion joints are normally located between section of bridges, railroad slabs, and piping systems. Also, expansion joints are expressed as control joints. So napod upat ka types ang expansion joints, which is the bridge, masonry, railway, pipe system expansion joint. So next slide please. Next slide please. Ito na. Okay. So ang longitudinal joint kay consists siya of a tie bar placed at the depth of a concrete pavement, and it is not intended for joint lateral movement. And lastly, the construction joint. Naay upat ka type sa construction joints, which is the butt type construction joint, tongue and groove construction joints, and the butt type with dowel construction joints, and lastly, the butt type with tie bar construction joints. So kaning longitudinal and construction joint, ako ra ni siyang ma-further discuss sa mga next slides na makuhan. So next slide please. So since year 1940, the provision for expansion joints at interval of 30 meters or less was almost universally practiced in road building. So the reason for providing expansion joint is to prevent blow-ups by relieving direct compressive stresses before reaching the stage of unmanageable level. So based on the studies of more than 5,000 blow-up samples, it was found out that blow-ups occurred mostly in the mid-afternoon at a temperature above 90 Fahrenheit during a period preceded by varying amount of precipitation. Next slide, please. So, so next is so mo na nitong type yapon siya sa ano, katong akong gingon ganina na upat ka buok, which is the apil na ang longitudinal joints. So in fact, next slide please. So longitudinal joints are provided between adjacent traffic lanes. It is considered as hinges to provide edge support but allows rotation between the slabs. By this joint, flexural stress that might cause irregular cracks along the length of the road are relieved or neutralized. So longitudinal joints cannot be considered as a major problem under the following assumption. So in fact, longitudinal joints are normally designed at a regular spacing, which is 4.5 meters, to accommodate the effect of differential settlement of pavement foundation. So ga-serve gyapon ni siya to cater the effect of warping concrete due to moisture and temperature gradients by permission for a kaning small amount of angular movement to occur so that stresses induced by restraint warping can be avoided. So naay six ka assumption, which is first is that there is no big load transfer across it. Then second is that the expansion and contraction movement developed across the pavement width is very small. Next slide, please. Third is when lanes are constructed at different time using side forms, the joints are provided with key way in the first slab to accept load transfer. And the fourth is for longitudinal joint, deformed tie bars are used because the purpose is to hold these slabs tightly together rather to allow the joints to open and close. Then fifth is the diameter and spacing of the tie bars based on the force needed to pull the narrow pavement slab over the subgrade to the joint. And lastly, the length of the tie bar is determined from the embedment inside the concrete necessary to develop the strength of the bar. So, ang flexural stress sa dalan or bend strength niya kay mag-cause lang og irregular cracks, tas gipasabot ana nga ang yang irregular crack kay na neutralized, it means dili ra kayo siya delikado. So mo ani kanang unom ka buok na assumption, na iyang assumption or reason nganong mo ani siya ang kaning gapahibalo nga mo nang dili kayo makonsider nga major problem ang longitudinal joints. Next slide please. So based sa drawing mo ani ang example, di ba? Ang longitudinal joints kay pa-straight siya nga mag-connect sa other concrete pavement. So mo na nitong naa ganina sa fifth, which is the deformed steel bar kanang nasa middle, which is to hold katong sa duha ka concrete bitaw. And ang gigamit ani nga type is kanang nasa drawing kaning deformed steel bar with concrete pavement sa right side, mo na siya ang tongue and groove, and ako pa na siyang i-explain later na type. So next slide please. So sa diri nga table, which is the recommended tie bars for longitudinal joints in concrete pavement, which is the 3.60 meter lane width. So there are type and grade of the steel, the working stress PSI, the pavement thickness, and napoy duha ka class sa bar, which is the 1/2 bar diameter and the 5/8 bar diameter. So napod siya lain-lain nga length meter o maximum spacing meter gyapon ang kaning unit. So ang grade sa type and grade kay grade 40 or axle steel. So ang working stress PSI niya ani is 30,000. So the pavement thickness centimeter, which is the 15, 20 and 25. So based sa duha ka bar diameter, lahi ang iyang length meter and lahi pod ang iyang maximum spacing. So sa 1/2 nga diameter sa bar diameter, 0.60 tanan yang length meter, then sa maximum spacing kay 1.20, if 15 ang yang thickness, kung 21, then kung 25.80. So ang for the 5/8 diameter, same lang gyapon ang yang length and same pod ang iyang maximum spacing. Not dili parehas sa 1/2 bar diameter na galaylayang spacing while ga-increase ang thickness sa pavement, but sa 5/8 nga bar diameter kay same lang ang iyang length meter o maximum spacing. So next slide please. So next is the construction joints. Next slide please. So if a concrete pouring will be interrupted for quite some time, that cold joint will be inevitable. So the practice is to provide transverse construction joints. Deformed tie bars are used to hold the tightly closed together. However, if the construction joint replaces a construction joint, the use of dowels is the alternative. So, mo ni siya ang example kanang nasa left side na siya wall diya, then concrete nga placed on day one. Kibali mo ni siya ang old, then na din na siya road based sa drawing na road form shuttering kung para i-stop bitaw diya lang siya tama ng katong gibuhos sa day one. Then next slide butangan ay next day butangan din na siya diya og mo na siya ng construction joint, which is na siya makita siya between sa new concrete na gibuhos then sa old concrete na gibuhos, which is makita po siya sa drawing nga concrete placed on day 2. Then ang construction joints kay can be in between o kaniya kung ingon na the existing and fresh concrete. So naay types sa construction joints, which is the butt type construction joints, the tongue and groove, the butt type with dowels, and the butt type with tie bars. So ang butt type construction joints kay one concrete slab means kay one concrete slabs is poured directly to up to another concrete slab, and the connection at the top of the two slabs is edge for aesthetics. Then the tongue and groove type is a type of woodworking joint that simplifies the installation process of wood boards and materials. And the butt type with dowels is this type of joint is done by just adding a metal or steel dowel in the between conventional butt joint. And then ang last which is the butt type with dowels, but ang yang ginagamit diri kay kaning tie bars. So this is the same as that of butt type construction joint with dowel, but the dowel used here is a tie bar. So next. So time na para mag icebreaker. Then maghatag lang ko kining 5 seconds lang gyapon, then maghatag lang gyapon ko go signal para mag-start sa pag-answer. So next slide. So first is ang atong pareha gyapon siya sa icebreaker ni sa akong groupmate, which is Eliona. Then number 1 is joints provide space allowance for the lengthening of the slab due to expansion. So ang time starts now. Okay na. So ang first nga naka-answer is si Hezam Analo. Next. So number 2 is joints that are provided between adjacent lines. Then sakto na daga naman po naka-answer. Naka-answer is ang una is si Altaw driver. Then lastly is ang number 3. It is a type of concrete joint that is used when a new section of concrete is poured adjacent to another concrete section. Kami ka mga bright. Sige, ang una is si Franz section. So, thank you. Mura to ang akong report na part.
So, good evening, everyone. Next slide, please. Steel reinforcement for concrete pavement joints are specified in the design to prevent the widening of cracks produced by shrinkage or thermal contraction. The reinforcement holds the fracture pieces in rigid contact, preserving the aggregate interlock and the intrusion of dirt or water. These reinforcing bars, however, is not intended to resist flexural stress being produced by loads or curling. Next. So the reinforcing steel bars are mounted in one layer along the mid-depth of the slab. The formula used in designing this reinforcement for concrete slab joint is AS is equal to LFW over 2S, wherein the AS is equal to area of steel cross-section per foot of slab. L is equal to length of slab between joints in feet. F is equal to coefficient of friction between the slab and the subgrade called the coefficient of subgrade. Resistance ranging from 1 to 2 with 1.5 recommended by ASH2 interim guide. W is equal to working stress in the reinforcing steel in pounds per square in ASH2 interim. Guide suggested working stress from 30,000 to 45,000 psi depending upon the type and grade of steel. Next. So welded wire fabrics are also used as reinforcement for concrete pavement made from cold-drawn steel wires having the following properties, wherein the minimum allowed tensile strength is equal to 80,000 psi, the yield strength is equal to 70,000, then the reinforcing bars of billet rail or axle steel yield strength among them from 40,000 to 75,000. Next. So, the subgrade and subbase for concrete pavement. Next. So, what is pumping? So, pumping is, nano na siya. Eliani, i-consider daw na nanong, ay, na. So, what is pumping? So, pumping is the ejection of water and subgrade soil through the joints and cracks along the edges of the concrete pavement. A repeated depression of pavement joints by heavy axle load is their activating factor in pumping. So, what are the possible causes of water on subgrade is also the possible causes for water and subgrade are first is the unsealed slabs, joints, and cracks allow the water to enter the pavement structure and accumulate under the slabs. Second, possible causes is high water table. Third is poor drainage. Fourth is the panel cracks or poor joint seals that allow water to infiltrate the underlying material. So, with the presence of water in a subgrade and churning it with the soil, it activates the fluid forming slurry that expelled to the surface. A continued pumping by heavy axle load will flush the soil from beneath the pavement to the effective locations. So failure of the joint will be noticed followed by transverse cracking or breaking of corners. One crack will invite more chances for pumping action. Joint failures and by cracking that will be progressive. So pumping is minimal where the subgrade had been constructed resistant to erosion by cement or bituminous treatment or when the pavement slab is underlain by properly graded granular materials. Next. So, despite the continued studies, researchers, and experimental development made, there is no assurance for an effective means of excluding free water from the under pavement joints, cracks, and edges. So far, the use of undercourses with drainage provision is being considered as solution to prevent pumping. Next. So, concrete proportions. So the fundamental rule to obtain good concrete is the proper selection of cement, aggregate, and water. Thus, first, first rule is the type 1 or type 2 cement is specified for concrete pavement. Step 2, water for concrete must be clean, free from acids, alkali, and oil. So water that is suited for drinking purposes is acceptable for mixing cement except water containing large amount of sulfate. Number three, if concrete is to be strong, sound, and durable, the aggregate must have similar properties. So, Good quality concrete must be clean, hard, strong, and have durable particles and be free of observed harmful chemicals, coatings of clay, or other contaminants that can affect hydration of cement. Next slide. So fourth, the mineral aggregate of concrete is about 75% of volume or about 80% of the weight of the normal pavement. It must be properly selected to be durable, blended for optimum efficiency, and properly controlled to produce consistent concrete strength, workability, finishability, and durability. So fifth, the maximum size of coarse aggregate is 2 inches. However, the use of larger aggregates, according to some experienced highway engineers, increases its length and durability. This precept is supported by reasons that with larger aggregate, less water is needed, thereby increasing the ratio of cement to water. Under the cement water ratio principle, concrete is stronger when water content is less. So therefore, a lower water content will reduce the potential for shrinkage and for cracking associated with the restrained volume change. Next. So item 311.2.1, Portland cement. Next. Item 3 so item 311.2.4 for water, when water is used in mixing, curing, other designated application shall be reasonably clean and free of soil, salt, acid, alkali, grass, or other substances injurious to the finished product. Water will be tested in accordance with and shall meet the requirements of item 714. Water Water which is drinkable may be used without test. Where the source of water is shallow, the intake shall be so enclosed as to exclude silt, mud, grass, or other foreign materials. Next. So next we find fine aggregate. I find aggregate item 311.2.2. Next. Next slide. So that is the grading require item 311.2. That's for fine aggregate. It's grading requirements for fine aggregate. Next. Item 311.2.3 for coarse aggregates. It shall consist of crushed stone, gravel, blast furnace slag, or other provable inert materials of similar characteristics or combinations thereof, having hard, strong, durable pieces and free from any adherent coatings. Next. So for coarse aggregate, that is also its item table 311.2, that is grading requirement for the coarse aggregates. Next. So therefore, in conclusion, changes in gradation, maximum size, unit weight, moisture content can all alter the character and performance of the concrete mix. So admixture. What is admixture? Admixture is a substance added in mixing to change the characteristic of the concrete mixture. There are varieties of admixture available, like the air entraining mixture, which is very common. Others like water reducer, retarder, accelerator, pozzolan, and plasticizer are also used. Next. So item 311.2 admixture. So, mo na siyang item. Next. So, mo ni siya ang ato ang admixtures, four cup admixture. So, explain nato is what is water reducer. So, water Water reducer, water reducing admixture is a concrete admixture that can reduce the water consumption for concrete mixing while maintaining the slump of concrete unchanged. It can disperse the cement particles, thereby improving its workability, reducing the unit water consumption, improving the fluidity of the concrete mixture, or reducing the unit cement consumption and saving cement. So, ang point sa water reducer is makagless kag gamit sa cement, makaless ka sa cement, but also you are maintaining the slump of concrete unchanged. Then what is retarder? Retarder are the mixture that slows down the chemical process of hydration so that the concrete remains plastic and workable for a long time. So retarders are preferred because it increases the setting time of concrete. It improves the workability of concrete. The appearance of the concrete is greatly improved. Drying, shrinkage, and creep rate are also increased. So, accelerator. Accelerator, an admixture that causes an increase in the rate of hydration of the hydraulic cement and thus shortens the time of setting, increases the rate of strength development, or both. Calcium chloride and sodium chloride are the most commonly used accelerating admixtures. Next is pozzolans. This type of admixtures are used as a cement replacements rather than cement additions. Adding pozzolans to an existing concrete mix without removing an equivalent amount of cement increases the paste content and decreases the water or cement ratio. Next. So that is the item 311.2.9 for calcium chloride or calcium nitrate. Next. So here, air entrainment. So what is air entrainment? Air entrainment is the entrapment of air in concrete mixture in the form of evenly distributed small bubbles. It is used to increase the concrete resistance to surface scaling caused by dicing with calcium or sodium chloride. Another working advantage of air entrainment is improving its workability and reduces bleeding in fresh concrete. So, the effectiveness of air entrainment is to increase the concrete durability that is influenced by first, percentage of air present in the mixture. Second is the grading of aggregates. Third is size and distribution of air bubbles. Therefore, air entrainment in concrete may be attained by using air entraining Portland cement or by air entraining admixture added to each batch of concrete while mix-ins. Next. So cement and water ratio, the strength and other desirable properties of concrete mixture varies depending upon the ratio of concrete to mixing water. So in a non-air-trained concrete with water cement ratio by weight of 5 gallons of water per bag of cement may have a compressive strength of about 5,300 psi in 28 days. So ayan, in a mixture of concrete with 7 gallons of water per bag of cement has developed strength of 3,700 psi only for 28 days. So durability, therefore, is dependent on the water-cement ratio that should be properly controlled to obtain richness of the paste. ASH to guide specifications for highway construction establish the maximum water-cement ratio at 6 gallons per bag of cement on normal conditions and 5% gallons per bag of cement for severe atmospheric conditions. Next. I think kumano na lang sa siguro na to ang ano sis mahuman na ang Gmail 2 minutes na lang ang nabilin. Mag-send na lang mi otro og link since 2 minutes na lang ang nabilin.